to pull my presentation over here, because if you blink, you'll miss it. I love how a single hand showed up when the question was asked, who's using Cypress? It seems like everyone is moving away from Cypress these days. Cypress is not cool anymore. I'm going to show you some examples nevertheless with Cypress, and I'll hopefully show you how you can make it stable. Anyways, thanks for having me. It's been a lot of fun so far, and I'm happy to be here and to be on this stage. You're an amazing audience. You have amazing energy. So let's give it to test. When I start my talks, I like to get a feel of who is in the room. Now I can see that there's one hand with Cypress as a Cypress user. So that puts a little bit of pressure on me. But what I like to do is to ask questions. But since there are lights hitting me, I'll try to do something different. Instead of raising hands, I'm going to be the one raising hand. And when I put it down, you'll do a single clap. Can you do that? We can try it right now. We can do 3, 2, 1. All right, so this is the voting system now. All right, let's try it out. I have a bunch of questions for you. So first of all, are you writing test? 3, 2, 1. All right, that's felt like the same sound. That's good. Has your end-to-end test ever failed? 3, 2, 1. All right, a little less coordinated, but seems we are still there. All right. Has your test ever failed and you weren't sure why? 3, 2, 1. Pretty much the same sound. Okay. Have you ever spent more than 1 hour debugging? 3, 2, 1. I hear no change. No, I'm not sure. Okay. Have you spent more than 2 hours? 3, 2, 1. Still the same? More than a day. 3, 2, 1. Okay, I felt it was little more silent. You don't have to clap for this one. That's okay. Hopefully I haven't resurfaced any past trauma. So let me try and see if we are... Okay, my notes were kind of out of sync, but now we're all good. All right, so if you answered yes to the latter questions, you may have experienced the frustrations that come with UI end-to-end tests. And this presentation is hopefully about possible ways of reducing those frustrations. So at the risk of half of the room leaving right now, I'm going to proceed to the next slide. Stop me if you've seen this already. No. Yeah, you probably know this model, right? End-to-end tests are costly and slow. Unit tests are cheap and fast. And I personally believe that this model is kind of outdated. We have much better tools nowadays, especially when it comes to cost of creating tests. It's not so high anymore, right? Tools like Cypress, Playwright made it very easy for us. And as a result, we have more of them. But I like to talk about this little guy, right? Because as I said, we have some great tools, but they all seem to be battling for speed of execution, right? How fast will the test run? That's what's interesting us. And I have read countless of blog posts comparing Playwright and Cypress or some other tools, and they're focusing on execution. But if you answered yes to, or if you clapped to any of the questions from before, you know that there's a difference between speed of execution and speed of maintenance, right? When we're talking about speed, usually the debugging takes much more time than executing a test on a pipeline. And it's funny that we sometimes don't even notice that this is what's actually taking most of our time. When it takes 30 minutes to run your tests in a pipeline, we as developers are happy to spend a month of our time migrating from one testing tool to another. Anyone recently migrated from Cypress to Playwright? Yeah? Maybe, yeah, one clap, thanks. Yeah, so we are happy to spend a month of our time so we can take it down from 30 minutes to 25 minutes. I don't think that's a good thing, right? And we do all this work because we believe that maintaining E2A tests is just too much work. We're still mentally kind of living at the top of the pyramid. But to be completely honest, I think in many ways we really are at the top of the pyramid. So here are some examples of what teams that I have been working with or companies that I have been helping sort of do when they're trying to fix a flaky test that takes a lot of maintenance, right? I've seen this strategy across many companies. So we have like muting test, quarantining a test, retrying a test, adding a longer timeout, reproducing a test locally, deleting a test, or as I like to call them, shock, denial, anger, bargaining, depression, acceptance. And these strategies exist because this is true. We have limited visibility into what's happening on CI. What happens in CI stays in CI. Oftentimes, what we are left with is simply error message that may look like this. Oh, I have scroll bars here. Lovely. Even better. I think it drives my point home even more. Yeah. End-to-end tests, when we write them, they usually copy a user story, some happy path or some kind of user story. So when an element is not found, like we have on the message, I think at the very top, it tells us nothing about what exactly has failed. It often happens like this, right? When a test ends up with an error like this, the problem is that the error that caused this problem might have happened a couple of steps before. So we need to investigate, right? And I want to share a couple of stories with you that start with maybe a mysterious message like this. And there are either stories are encountered personally or with our clients at Replay. One of those clients is Metabase. Metabase is a business intelligence software. What's really beautiful, they're open source. You can take a look at their whole code, and I recommend if you want to see how a large test suite looks like. And we helped them drive down their flakes. We didn't have to do that, but we like to do that because we learn a lot by working with our clients. In fact, if you want to try Replay, you can totally do that on your own. But we helped them, and they had hundreds and hundreds of end-to-end tests and quite a bit of test flake. So with integration of Replay, we were able to drive it down to 0. And 0, like on their main branch, they still have like a couple of flakes when they introduce a new branch, but they can be fixed quite quickly. So I want to share one story. It starts with a test like this. It's a missing spinner. It's a fairly simple test. The team wanted to make sure that user with slow connections know what's happening. And they will see an animation loading spinner, right? It has an ID, so we're waiting for that. It should be visible, it should appear. But this test failed over and over, which was strange because the code that it was testing has not changed. Anyone had that experience? Test started failing without apparent change to the code? Yeah, clap, thank you. And this was frustrating for developers. Like, what's happening? So we recorded their test with Replay browser. We ran it on their CI and started debugging. So this is a view of what you see here is Replay DevTools. And on the left side, as the video zooms, you can see the number of executions. Not sure how well you can see that, but there's like a little number 27 in a blue box. That means that line of code was executed 27 times. And when we record things happening on CI, you can travel to like every execution of that line of code, as you can see with the click on annotation at the bottom. So as we travel, you can see that as I click, you'll see that spinner appear. So there was clearly a moment in the code execution where that spinner element appeared. So the problem, why is the test failing if the element does appear? Well, the problem was that that code ran too fast for the test to catch it. But Metabase team was kind of smart enough to think about this, and they have implemented a strategy. So this is again some Cypress code. You can see the intercept at the bottom. So they decided to throttle the API request that was sort of responsible for getting some resources, and while it was doing that, the spinner animation would appear. So they decided to throttle that that request and limit the amount of kilobits per second, which is very smart. But there's one catch. The response from this URL, because this test will resolve in different time if the response has, for example, 100 kilobytes versus when it has 1 megabyte. So in the end, when the response from this URL was smaller, the test ran faster, or the code ran faster. And the spinner showed for a shorter period of time. In fact, it showed for such a short time that Cypress was not able to catch it. So in the end, the solution that was implemented to make the test stable was very simple. Instead of the set throttle function, they've used set delay, and the test was fixed. And this is largely thanks to the fact that we were able to time travel and to jump into that line of code and see what was happening in there. And we saw that this was actually not a problem of the spinner not appearing, but it was actually a problem of the network. All right. Story number 2 is actually also from Metabase. And this actually inspired the name of this presentation, Blink and You Miss It. In fact, I'm going to show you a screenshot from a failing and passing test side by side, and you can tell me if you see a difference. If you see a difference, you got amazing eyes. I'm going to show that in a video. Maybe now you might be able to see it. Do you see the difference? Beautiful, right? So I'm going to tell you straight away that it was a font change that caused this test to fail. Amazing, right? And it was a simple CSS change, but what's really interesting is how it actually affected the functional side of a test. So this was the error message, and this was like the most confusing part of it, because there was nothing that pointed to a problem with CSS. In fact, this looked like a functional error, because we expected a certain date range that started on April 1st, but it actually shown May 1st at the beginning. So what was this all about? To give you a better idea of what the test did, here's the test code. And what the test was trying to do is it would have this set of commands that would trigger sort of mouse down, mouse move, and mouse up. Right? There were certain coordinates to coordinate the action, and it was sort of a drag and drop action to select a certain date range. And then it would validate that range, the range was in fact selected. Now, first of all, when we looked at the error message, the logical thing, or the place to start, would be to take a look at the network log that was recorded, right? So we looked at the range, and actually you can see at the bottom it did select the May 1st, right? So our test was doing something we didn't expect. It just didn't behave the way we wanted. Going back to the video comparison, we can see why the test did not work the way we wanted. It was because the CSS change caused a layout shift, right? And the test was actually relying on a certain coordinate. So when that CSS change happened, it was actually selecting a slightly different range, and that caused the error. So yeah, that was fun to find. All right. The next example is kind of a very common one: race condition. Right? When we are writing end-to-end tests, essentially what we're doing is we're trying to integrate two systems. We have the app code, that's system 1, and then we have the test code, system 2. We try to integrate them together to work, to cooperate, and we end up in an integration hell that causes us to tear our hair. All right. So if you do testing, there are chances you have already seen an issue like this. So I'm going to show you an example, and I'm actually going to debug this one with you. So here's an example with like a sneaker e-commerce site, and there we have a Cypress test that attempts to buy a sneaker. And it's flaky. Sometimes it passes, sometimes it doesn't. And when it fails, what happens is that we actually click on the button Add to Cart too soon. And you can see that indicated with two things. First of all, there's the error message, cannot add 0 items to cart, right below the button. And above the button, there's this counter component that shows 0, and above that, there's the no available message. So it seems like the application is still loading some stuff, but we clicked the button way too soon. So we fixed the test, first of all, by adding waiting so that the test does not go too fast. But this is a slippery slope, right? Because we may be increasing that time, but not really fixing the real problem. Real users can actually have this problem if they have like a slower network, and they can also click the Add to Cart button too soon. So I like to say that when we run our tests on CI and we find some problem with the test running too fast, what we're actually doing is exposing the problems that our real users would have, because I hear the counter argument sometimes, oh, it's not really like a real use case because CI is just running too darn fast. So I kind of disagree here. All right, so let's debug this together. So what do we know? We know that test opens a page and clicks on Add to Cart button. We know that test sometimes passes and sometimes fails. The error says could not find the text product added to cart. The counter shows number 0. The test seems to click the Add to Cart button too soon. And the test runs OK locally, but fails on CI. All right, I'm getting ahead of myself. So let's do a little demo, and this is going to be fun because I'm actually going to be doing this on a separate screen, and I already see there's like a delay in my cursor, so that's fine. Okay, so here's a recording or a replay of our test. I can play this like a video and see what happened. Let's try this. All right, so I have a Cypress test. It opens the app, it fails, and then it retries and runs that test again. Okay, pretty cool. Not much to see here. So what I'm going to do is now I'm going to open this Cypress panel, and here I see my two tests. I see the failed attempt and I see the passing attempt, and I can compare and contrast and see what's going on in the passing and in the failing case. So I'm going to open the failing case, and what I can see now is list of all of my commands, and I can also see the XHR requests. Okay, this is kind of hard because I have a slight delay, but let's work together. All right. So I have a list of my commands, see visit, contains, I have some assertions, and I have this click action. So it highlights where the test was trying to click. So we already know this is not a video. And here I have this jump to code button, which is kind of a fun one, because I'm now in my test script, but what I can do, what will happen when I jump to code, it will jump to the actual code that was executed, right? So I can see my product detail component that makes this app, and I can see the exact line of code that was ran when I clicked, or when the test clicked on the button. So let me hide this for a moment, and let's see what this is doing. So it's actually calling a API add to cart. So it's making some network request. So what I can do, I can go ahead to network panel and check it out and see what's happening in here. And there's a lot, so let me just filter out just the fetch and XHR. And here I see 3 API calls. So we got check availability. I can take a look at the response. Apparently it says quantity was 1. All right, and then I have add to cart, which says the error message, and I can take a look at the request. Okay, So let's debug this. What does this add to cart function actually do? It calls the API call, it sends a certain body, and then we have this quantity, which is the thing that we're sending over here. Now, sorry, looking at the request, I can see that the quantity is 0, but what I can actually do is I can click on this plus symbol and do, this is basically a inside of a brackets of a console log. So if I do hello world and I just put it in like this and look into my console, I'll see my hello world. Well, that's not interesting. Let's put in the quantity so we can actually see what we have been sending towards the server. And it says 0. Okay, so what does it do when I look at my passing test? Let's go check out the passing test. And indeed, the number is different. So we're sending number 1 over here. So I'm going to continue on debugging, and I'll actually annotate it a little better so we can see what's going on. Send to server, and let's give it a color purple. Font size, yeah, sure. Here we go. Is that better? More? All right. Okay, there's a lot to to do here. I have the delay and I have the font size. Okay. No, that's okay. That's thank you, because that would be a lousy presentation if you couldn't see anything. All right, so we keep on debugging. That's what we sent to the server. Right now we're in the passing test. So what is this quantity? Where does it come from? Well, let's search. I'm going to type Command F and search for quantity. Here we go. So I can see it over here. I can see it over here in the counter. That makes sense. Let's scroll to the top to see where it is defined. All right, so it's a state variable. We see quantity. We see the set quantity function. So let's actually search for that and see where our set quantity is being used. And here we go. All right, we have some use effect, and I've added some comments here. So we have update, quantity, and availability. So it seems that we're updating this at some point. Where does the data come from? Well, it comes from over here, line 31. Where does that come from? From the fetch availability function, which calls our check availability. That makes sense. We first check how many sneakers we have in the store, and then we update the counter and whatnot. So let's add another console log in here, and I'm going to do availability and just do the data QTY, and let's give it a green color. Okay, all right, so we got availability 1 sent to server 1. And again, this is our passing test, right? So let's try to compare that to our failing test. I'm going to go back, take a look at our failing test, and now I can see the difference, right? We have the sent to server 0 and availability 1. But what's interesting is the order of these, right? So these, I keep calling them console logs because they're essentially that. It's as if you forgot to delete console log from your code, but I'm adding that to something that already happened. So I see that in here, we first send to the server the information and then do the availability. So we got this weird race condition where we click on the add to cart button and send this request with the default value of 0 before we actually get the information back from server. And this is how you could debug your test yourself. And I'm showing a lot of like Cypress, but you can use this with Playwright as well. So let's now fix the problem, right? I love the term flaky test because sometimes what ends up being flaky is either the environment or the application itself. So there's one way of how we could fix this, and we could take a look at the add to cart button and add another attribute. So we can essentially try to disable the button, and if the quantity is 0, it's going to have the isDisabled property, which we will add to the button component. add some property and some tailwind styling, and we're done. Now, our test, as a result, it will become cleaner. So now here's the video of that same test running, but now the test is not failing because the add to cart button is disabled, and we actually don't even have to have that wait now because retryability checks in Cypress and in Playwright do that for us. They will check the interactivity before they interact with anything. And so this is what you as developer or a tester should do, right? When we talk about flakiness or flaky tests, we need to take into account both of those systems. We need to take into account the application and the test itself. So yeah, I'm very confident that in 90% of what we call flaky test is actually flaky app. And it has nothing to do with the test code itself. In fact, this is how probably the test code should look like. All right, let's go back to this slide, right? How to improve the test speed. These are just a couple of stories that are shared. There's definitely more, and we have a coffee break right after my talk, so I would love to share some with you. Come talk to me. Don't be shy. I'm shy. So you need to come to me. Yeah, so, but here's the thing about speed, right? As I mentioned, we obsess over the speed of execution of our test. Like, which is faster? Is it Playwright? Is it Cypress? Whatever. This is the speed we actually need to be looking at, right? Because if writing tests takes this amount of time and debugging takes this amount of time, you should probably care about this one. In fact, I had a poll, I didn't include the picture here, but I did a poll on LinkedIn recently where I asked, like, what takes bigger part of your day? Is it writing tests or debugging tests? And overwhelming majority, I think it was like 72% said that debugging tests takes bigger part of the day. And yet, when Cypress tests are falling, we're migrating it all to Playwright. Don't get me wrong, Playwright is cool. You should do that, but not because your tests are flaky. They're probably going to be flaky in Playwright as well. Maybe, I don't know. So only by driving down debugging time is how we can achieve real speed improvements, the speed improvements that matter. And all the flakes that I have shown you would normally take hours or days if you try to replicate them locally, right? That's the depression part of our fixing strategies. But when you have the option to time travel, you can take it down to minutes. So I hope you like that. If you want to try replay, here's a QR code. If you want to see my slides, there's the other QR code. And if you want to talk to me, I'd be happy to. Thank you very much, and enjoy the rest of the conference.